It was the one where they had the quadcopter actually come flying in through the keynote. They dropped the Coke bottles off at the... I was like sitting there, well, that's kind of dangerous. But it was also quite fascinating. And in the dev zone that year, they had a little vending machine and you could win prizes. And I won one and there was a quadcopter in there and I got my first quadcopter. I thought that was quite great.
That's Daniel Ballinger, a Salesforce MVP and a developer at FuseIT over in New Zealand. I wanted to sit down with Dan and talk about his history with IoT and how he likes to tinker with things, including drones that he happens to win at vending machines. My name's Joshua Burke. I'm a developer evangelist at Salesforce, and on the Salesforce Developer Podcast, you'll hear stories, insights, and information by developers for developers. Now today, we're talking Internet of Things with Daniel, and the whole drone scenario would pick back up again when Daniel was talking about a science project at a meetup.
Well, we did this talk in Auckland to the user groups, and I was talking about how I was really into drones. Somebody else at the time had been talking about, they'd been doing a science project with their kids, and it's like, how do we, because in New Zealand, possums are like a introduced species. They're not native, and they compete with all the native animals for food sources, so they're actually a pest problem. So the Department of Conservation put traps and such out to try and reduce their numbers. But of course, somebody has to go out to those traps and monitor them and everything. And so their son had done a project where they put like a cell phone on a trap and it would relay data back to say, I've gone off. They did quite well with that. And I thought, oh, okay, hang on, I could kind of bring all these things together. Because the problem is with their one, it's great as a concept, but putting a cell phone on every trap gets quite expensive. And the traps are usually in places where cell phone reception isn't that great or even possible. I sort of thought, I can kind of bring this all together. So what if I put something really cheap on the trap, like a little RF transmitter? You can get them for $1 or so, and it would just send out a blip when it was ready, when it had gone off or something. And then I put the expensive part on a quadcopter that could fly a loop around all the traps, get the little basic signal and know where it was when it happened. And then I could relay that data back into Salesforce and run the automation from there. And also, once it's in Salesforce, you can do all sorts of things, like you can start plotting out the positions and seeing, oh, hang on, these traps in this area are all going off a lot and these ones over here aren't. And so maybe I need more traps in this area and things like that. It's quite interesting. To get this to work, I actually built a larger quadcopter so that it could carry the weight of a Raspberry Pi and keep flying for a while. And you had to pull power off the quadcopter to get the Raspberry Pi going. And the Pi's job was basically look out for the signal and record the GPS position, which it does. And the quadcopter's job is fly the circuit, because you don't really want the Raspberry Pi involved in the tight loop of trying to fly the quadcopter, because it was interrupt based and you don't really want that for like, it's great when it's like a signal is coming. You don't really want it pausing for a while. You'll plow into the side of a hill or something.
Okay, so solid pro tip there. If your Internet of Things project includes flying things, make sure you don't interrupt them in the middle of said flight. Now, the next question I had for Dan was, how does all of this integrate back to Salesforce?
So there's sort of two parts of it. At the start, you could, because you have your position of all the traps in Salesforce, so you can use that at the start for sort of like flight planning. It's like, I want to fly this circuit. How can I visit these nodes with the least amount of travel? And I never actually completed that bit, but I sort of thought about it. It's like, I need to fly a circuit. I want to do it in the quickest way possible. Yeah, I'd thought about it, but I sort of got distracted with other projects. But so there's that part that sort of, let's do the flight and the mission planning, where we're going to go. And then the other part is, once the quadcopter is actually up in the air, it's a good chance it's going to be out of cell phone range as well, or any sort of reception in that respect. No Wi-Fi, no network, it's out there. But that was the whole point, as it flies the circuit, gets the data, brings it back to somewhere in range. And then you just do a large push through the APIs back into Salesforce. It's like, I was at this position and I received this signal. And then you sort of have to correlate that back to where you know the traps are to try and say, okay, this trap was the one that was sending me the signal. And now you've got all the data in Salesforce and you can say, these traps have gone off, they need attention. And then I was kind of going down the path, but didn't really, like this field service lightning as in Salesforce, where you can say, okay, who's the closest person or who's the suitable person to go to these traps and do whatever they need done to them.
And like with a lot of things related to the Internet of Things, Dan has a philosophy on the hardware. Keep it simple.
Yeah, well, I didn't want to make the physical components too complex or too expensive, especially on the trap side, because you don't want lots of expensive electronics sitting out there unattended. Yeah, it's like free cell phone. You want something pretty uninteresting that has a minimal battery requirement that can sit out there for months, sending a little blip when it needs to. And the quadcopter itself, yeah, I mean, like the autonomous flight, So a lot of people have already spent a lot of time solving that problem. You don't want to sort of reinvent all that. You want it to be able to do what it's good at. And you sort of just piggyback the Raspberry Pi underneath and say, your one job is watch for that blip and record where you are.
So Dan gets the project up and running from a technical point of view, at least. But the Department of Conservation, which he had been in conversation with, they're talking about it. But at the end of the day, they kind of already have rangers doing this. So it's a very interesting tech project, but eventually Dan moves on to one of the other things that I'm actually surprised doesn't intersect with the internet things more often, that being cats.
We had a bunch of neighbors, several neighbors had cats. Fine. Except the cats, they didn't really have much of a backyard, but we did. So the cats would all sort of congregate or come through our backyard and they'd do, let's say, their cat business. In the backyard. And I had young kids, 4 and 6 or so, around that age group. And there's all these cat deposits, and they'd also catch birds and leave parts of birds around, which is not so. I mean, the kids are whatever, but
right.
Yeah, so it wasn't great. So I spoke to the neighbours about it, and they said, "Oh, just get the hose and give them a wave in that direction, and they'll run away." And it's well, that works, but it's not really practical for me to be out there 24/7 chasing cats away.
I mean, you're not in retirement yet. That might be a retirement plan.
So I'd gone on, I think AliExpress is sort of like Amazon or something. We'd found a little RF sensor-based sprinkler system. So it was a unit. You just plug it into the hose, and the second it sees motion on it, it turns a sprinkler head on, and it goes and scares the cats away. It was also used for deer and things. We don't have deer, but yeah, it would scare the cats away, and that's great. But the sensor on this thing, it's a motion sensor. It doesn't care what's in front of it. It will spray everything. It's just even a tree waving in the wind.
And it just goes off.
It goes
Right.
half of it is actually the noise scares the cats away. They hear the noise and the water sprays everywhere, and they just bolt, and it's fine. They don't hardly actually get wet.
But you also want your kids to be able to play in the yard. So,
Yeah. So you want to be able to see this thing set up. Otherwise, I've just made myself another job of maintaining this thing. So it was about that time Salesforce had acquired, was it MetaMind? It became Einstein Vision, and they say, here's the API. So I started playing with that, and then I realized this would actually be really good because I can give it an image of what's in front of the sprinkler, and it could tell me, is there a cat there? So as a proof of concept, I got a webcam on a PC. So you capture the image and say, give me a prediction. You have to train up your model and say, what am I actually seeing? And luckily for me, pictures of cats are prolific. So it wasn't too hard to train it to say, this is a cat.
It does power the internet.
Yeah. And so what I ended up with, so the cat walks in front of the camera. I'd had some software in C# taking the images from the feed from the camera, and it was doing comparison between each image it's seen, so it could detect motion. So when it saw motion, and the nice thing was you could put a bounding box on it to say, if you see motion on this grassy area, because you don't want to see the tree swaying, capture the image and send it to Einstein Vision REST API. That would come back and say, here's the probability of such and such, or here's the probability of what I think I saw in it. And if the probability that there was a cat in it was high, now because this was a prototype, I think I actually had a USB connection over TTL to the Raspberry Pi, which just had a relay on it. So I could stick the pin high, the relay would turn on. I just drilled out the bottom of the water turret and put the power on through that. So you could turn the sensitivity way up on the turret, and then the second it got power, it would just go. So I put that pin high for, 3 or 4 seconds. The turret goes, and then it turns off. And then I repeat the cycle. And so if a cat walks in front, sees the motion, takes the image, gets the prediction, thinks, yes, there's a cat there, turns the sprinkler on, and the cat's gone. The kind of nice thing about that loop was it maybe took a second or two for it to finish. So if the cat was just coming and going, it's whatever, the cat would be gone by the time it had even gone off. But if it comes and stays, it's going to get scared off. And it was funny, as I was testing it, I had it hooked up to the hose, and then it must have popped off the tap or the faucet outside. I was oh no, I've got to go out and fix that. So I don't even think, I just walk down past the turret, down to the tap, plug it back in, walk back up. So the thing's all pressured, and then I walk in front of the sensor, and I sit down in front of the computer, and there's a picture of me and the probability that said, oh, you're not a cat. And I was oh man, I could have just, it works. I could have blasted myself. It would have been quite funny to blast myself with the hose. But
okay. So we have quadcopters that can fly around on their own, detecting possum traps. We have a cat deterrent system, which can correctly identify that Dan is not a cat. And for his next trick, well, this was actually where Dan and I crossed paths at one point, because we were looking to have something that was a little bit more robotic for the IoT Zone when I was running it for Dreamforce. And we looked at what Dan was doing when it came to Astro driving a car.
They kind of came hand in hand. So there's a self-driving Lego car in the Astro one, and I needed a way to train the model continuously in a loop. It's quite hard to train it by hand, trying to take images with a camera. You really want images as it would be seeing it. So I set up this other rig where it was basically a camera looking at a screen, and I think it was actually Google Street View. I'd driven around, or I'd taken images out of Google Street View continuously going around windy roads that you could feed it in sequence. And then I had and this is the same Raspberry Pi taking the image and figuring out what it should do. And then I would sit there looking at the images coming into the camera from the Raspberry Pi and deciding what degree of left or right or straight should I be turning. And that would feed into the MetaMind or Einstein Vision model what I said I should do for each of those images. And it would sort of build the model up that way. Say, when you see this, I expect you to do this. And if you do that enough loops, and it actually got quite good at predicting which way it should turn. I mean, you also had to be careful about what images you were feeding it. Like, you didn't want images where there was a car in front of you, because you'd end up training it on the car, not on the road. And if you didn't have enough images in your test set, it wouldn't work. And again, this comes back to the real world. It's a lot less forgiving. That one, I took Astro and I glued him into a chair, or I cable tied him into a chair. Actually, I put a servo coming off the Raspberry Pi PWM again, so you could see which direction it thought it was turning. Because this could have came back to how would I automate this on the actual car. And then I attached Astro's hands to the steering wheel so that when the servo moved the steering wheel, Astro moved corresponding. And just because it was a self-driving car, I took Astro's eyes out and put a Larsen scanner, like you might have seen in Knight Rider, where his eyes were. There's those lights, LEDs that flash backwards and forwards. That was just because. So yeah, Astro would sit there and he would steer, I don't know, get that right. They would steer the way they thought it was going.
Now, Dan does have a current project that's in the works, shall we say. And talking about it, you do learn a couple things. First of all, how his inspiration kind of works. And also, this project might have a few logistical complications.
Have you seen the movie Inception?
I have.
And so they had that whole concept of Inception as like, you get this idea in your head, and it's going to stick with you. It's going to, like, most contagious thing is you're not going to be able to get rid of that idea.
Right. It's that seed that you just eventually cannot ignore.
So shortly after I'd done my Einstein self-vision, somebody was talking about an Astro again and how it originally was in a spacesuit up in space. And I was like, wouldn't it be funny to send Astro up to space? And I was like, well, what if you put Astro on a weather balloon? You could get I mean, obviously it's not space,
right?
But you'll get pretty close.
Really close. You can see space from there.
Yeah, like if you put a GoPro or something on the weather balloon, the perspective, especially with the curvature of the GoPro lens, and the fact that the sky becomes dark when you get up that high, it looks like space. It's space enough.
Yeah.
It's like, I could do that. It's like, well, now I've got something that I want to do. What's the problem I'm actually trying to solve other than sending Astro up really, 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 really high? And it's like, how could I integrate that back to Salesforce on my own? I know I can get like telemetry from the weather balloon, so you can get like temperature, atmospheric pressure,
altitude,
humidity, altitude, GPS position. Although it's like now you're down the rabbit hole. It's like, well, what happens when you send a GPS module up that high? Well, it turns out most off-the-shelf GPS modules won't work at that altitude, because you can potentially get to like twice the height that airliners fly at. So you're going to get up there.
At that point, where X, Y, and Z is not quite as calculated as when you're actually on the ground.
Yeah, a lot of like off-the-shelf GPS modules just aren't going to handle that.
Yeah.
And then there's temperatures, like you're getting well below freezing. Well below freezing. I don't know if you've ever watched it like in a plane where it says like outside air temperature.
Right.
And then you're going to go to potentially twice that altitude. So thinking like, I can gather all this data. What am I going to do with the data? I'm going to send it back to Salesforce. How am I going to send it back to Salesforce? Well, cell phone's not going to work. There's no Wi-Fi. So yeah, I've been looking at that sort of like how to get the data back. Maybe you could do it via a satellite connection, which is not cheap.
Right.
I've looked at that. It is not cheap at all.
I'd assume a weather balloon isn't cheap.
Well, the balloon itself is not too bad. It's filling it with helium, which is expensive.
Which is in a lot of helium, I would guess.
It's a lot of helium, like several cubic meters of helium, and you're running into the several hundreds of dollars just for the gas. You could actually do it cheap and use hydrogen, but I suspect that's a mistake you might only use once.
Right. I have a cast fireball spell joke in there somewhere.
Yeah. It's like one spark and you got a large bomb on your head. I've been thinking about that, and it's like, how do you get the data back? Like, there's something called the amateur packet radio system.
Okay.
Which you need like a ham radio license. So I'd have to go off and sit a license, which would require me to remember all the stuff I learned at university about antenna attenuation and how to make certain circuits.
Right.
And then, but like if you got that, then you're allowed to transmit packets out on the radio system. And there's a whole bunch of stations around the country that will receive those signals and put them into internet traffic, which I could then send to Salesforce and complete the automation.
And that's our show. I truly wish Dan a lot of luck with trying to send Astro back into space. We will be tracking that project and might bring Dan back to the podcast if we ever reach that kind of altitude. Now, before we go, I want to point out that Dan and I have a few things in common. We've tinkered with the Internet of Things in the past. We've worked with Salesforce, but we also had some early geek history when it came to modifying video games.
I'm much more interested and proficient at CAD-based design because I was playing at home I was tinkering with Duke Nukem and building my own levels, and like I'd replicated my parents' house in a video game, which I thought was quite impressive at the time because I don't know if you've ever looked at the Duke Nukem levels. They weren't true 3D. They were like, they called them 2.5. They sort of wrapped around themselves to give the illusion of depth or like height. Yeah, so I was actually reasonably proficient at CAD, but that wasn't really part of the curriculum at the stage.
I've always said that programming can be a lot of fun to learn if you're trying to figure out how to make a grenade do exactly what you want. Thanks for listening, everybody. If you want to learn more about this podcast, head on over to developer.salesforce.com/podcast, where you will find more information, current episodes, and links to your favorite services so that you can like and subscribe. I'll talk to you next week.